Welcome to part one of my series in SIP panel construction with Green Edge Homes in Florida. I was very fortunate to be able to have some time with Brian Bishop of Green Edge Homes to sit down and ask a whole slew of questions. So if you're curious about the technical side of things that goes into these SIP panels, by all means, have a seat, have a listen. If you've got some questions, put them in the comments and I'll see if I'm able to answer them or find someone that has the answers for you. Enjoy.
Hi, Brian.
Good morning.
Super happy to be able to check all this out and see everything that you did yesterday. It was really cool seeing how the panels were put together. And so I sat down and had a whole slew of questions.
Good.
The panels are made with wood, glue, and then wood for the roofs. that I
Yeah,
saw.
so the roofs are a composite panel and they're 7.5-inch foam core, usually in this climate zone, maybe from North Carolina to the Caribbean. 7.5 is what you want to meet the energy demand. And then it's got 5/8 zip board, which is formaldehyde free plywood
Right.
on each side. So 5/8 will meet the attachment for any roofing in the world. For International Building Code, you have to meet that attachment. That's thick enough to attach in high velocity winds up to 200 miles an hour.
So how much thicker does it have to be north of that?
So it can be as thick as we want, right? But there's a diminished return when you get too thick. There's other reasons. There might be an architectural reason for commercial or modern architecture where you want a really thick roof, or you might want a very thin roof. But I would say in Alaska, 12 inches, right? And in Florida, 7.5 inches.
Okay.
That'd be the range.
Are the roofing panels that you use, are they capable of making like an A-frame?
Yeah, so there's no trusses. This is a clear span, so the panels can span 19 feet between supports with no intermediate support. So that's at 200 mile an hour, 45 pounds a square foot. They're tested up to 55 pounds a square foot, and 100% rebound. So they can take that maximum load in a hurricane, and then 98% rebound is guaranteed.
How would those handle a snow load then?
So snow load is the same as a hurricane, right?
Is it? Okay.
It's just a load. The panels are tested for 30 days static load with 5,000 pounds.
Right.
And that's part of the Florida Building Code and International Code, that they have to rebound 98% after 30 days of the load applied.
Oh, wow.
Yeah.
So you could theoretically do 2 panels up on each side and have an actual A-frame cabin.
Oh yeah, we could, listen, I can make the panel, I have a patented spline system where I can make it 50 feet long. The only rule is every 20 feet we have to have some kind of a support. So you could go 20 feet, you could go 50 feet, but you'd have an intermediate ridge, right? So you
Right.
have one ridge and go 20 feet. You want an A-frame of 50 foot tall or 30 foot tall. There'd be 2 more intermediate ridges. Or there might be some other structural members embedded in the panel that we would design. So you could put a steel tube every so often to give it extra strength in bending.
That would be
Yeah.
fantastic.
Yeah. So these are tested, in the labs in Miami. We spent $1 million testing them. The walls, the floor, the roof, large missile impact 2x4 cannons are shot at it, and then 9,000 wind loads up to 200 miles an hour, negative and positive. As if a hurricane was coming, it was negative pressure, and as it passes, it becomes positive pressure. So you have to do 9,000 cycles after you've impacted it 3 times on each specimen, and 3 specimens for each type. So it's a very rigorous, but that's the ASTM testing protocol for International Building Code.
What kind of insulation value does that give at what you're using here?
So polystyrene is closed cell, so moisture won't absorb into it, and it's also borate treated for insects, although insects don't want it if there's no moisture in it. And so we get about R4 per inch at 70 degrees. So actually, weirdly, the R value goes up as it gets colder.
Right.
A little bit.
The next question I had was actually with your process, what's the weakest part essentially? So adhesive that you use to go to the outside panel, or is it the adhesive, or would it be the insulation itself?
On the panel itself.
Mm-hmm.
So the thing about the way these composite panels work is, just think of a 6x6 beam, a column, let's say, a pressure treated wood, and just make it 4 feet long, right? So when we attach at the bottom, we attach at the top, and that's the load path. So extremely strong in compression and tension, right? So the panels are just off the chart strong for a building material. A 6-inch thick cement board, hardy board panel, 4x8 by 6 inches thick, would take about 9,000 pounds to break in half if you put it on really strong sawhorses and loaded it up.
Right.
But then it's got a 6x6 on the edge if it's a 6-inch wall, so it's astronomically strong. The way it's fastened is there's there'd be a nail or a screw every 4 inches through the cement board at the bottom,
Right.
holding it down to a base plate. So the load path on a slab is concrete, anchor bolt to the base plate. The base plate, that's an easy math because it's easy to calculate the withdrawal of the bolt through the wood. The panel goes over, it's nailed. You get 1,000 pounds per set of nails, one inside, one outside. So and then at the top, it's nailed again, and then there's a big lag screw. Each lag screw, 4 per panel, gives you 1,000 pounds each screw. So the load path is extremely simple.
This is like easier than Legos.
Well, it is, and the weakest part of it is so strong that it will exceed 200 mile an hour winds. So the weakest part, for instance, on the houses we're building in Florida, maybe an average 3-bedroom, 2-bath house, just the nails going into the base plate through the panel will develop about 1/3 pounds of uplift with no straps, just nailed to the thing.
Mm-hmm.
So that says, well, then I'd be thinking about the bolts holding it down, right? Because that makes it the weaker. At some point in the assembly, there's something that's the weakest. Funny, I built my house, and I built it. It was sunny and beautiful out, and I put the screws in on the roof that were necessary for the 200 mile an hour wind load, right? And it was sunny. And if it was a hurricane, I would have put more screws in. And when I was standing in the house at 200 miles an hour, I look at the roof, and I know it works because I've done all the tests, and I've built many of them, and they've been through disasters. But I still thought, son of a gun, I should have put. Why didn't I put more screws in that roof? Mm-hmm. I know it's strong enough, but I could have made it twice as strong for $300, right?
Right.
But the problem is when we're building houses, it's sunny outside. We're not thinking disasters.
Right.
We're doing what the plans say. If it says a nail every 8 inches, you put a nail every 8 inches. Mm-hmm. Like if you knew a hurricane was offshore, you'd be putting them every 4 inches.
Right.
So load path is important. It's everything about all construction, but especially with us because there's so few parts. Mm-hmm. You got a wall, you got a connection here, you got a roof, you got a connection, you have a connection at the ridge. You have three locations that you really have to fasten it properly.
Right. Do you have to use any sort of sealant on, like, say, the screws going into the metal roof, going into the roof panel itself?
No. So most code in any sophisticated building areas, in Florida and Georgia, North, South Carolina, if you're in a real rural area, maybe the building departments are lax and they have like local practices. But the whole world really requires a underlayment. Mm-hmm. We've left tar paper behind for years, and now it's ice shield down here. We call it a peel and stick. Secondary membrane is the technical term for it.
Right. It's
like ice shield, what you guys would call it.
Mm-hmm.
And we cover the whole roof with that because the code requires that if the roof flies off, which if it's put on properly, it won't. But if it flew off, then the secondary membrane is supposed to protect the house from damage, and it really does. My house, a giant tree hit it, a 140-foot tree during Hurricane Ian. It thrashed around, tore all the metal off the roof, but it left the tar paper, the peel and stick on. The house leaked a little bit, but it saved the house, right? So
wow. So
that's right. So it doesn't hurt it, and supposedly it self-seals around the screw or the nail when it goes through.
That's kind of where I was wondering.
And it does. But it's like everything in life. You know, if you put a roof on a house, and 30 years later you took it off, you might find a little spot here or there you have to touch up.
Mm-hmm.
It's just, you know, it's not.
Well, you
it's not
can't.
perfect.
You can't make anything completely indestructible.
Yeah, that's
yet.
right.
Yet.
Yeah,
You
well,
haven't
we're
got there
working-
yet.
We're heading there. Nice.
Yeah. Any of these homes been put in the north yet?
So we have built in what's our furthest north? Well, Washington D.C., Delaware area. We did some charity housing for handicap families.
That's fantastic.
Yeah, we did 4 homes in Silver Springs, Maryland, actually, and we've built in Texas. We built all through the Caribbean, and then if you took an arc from like Delaware to Texas, that's the range. But remember, I asked my energy modeler who helped me 20 years ago when we got started. You know, well, how does this perform in like really cold? Well, is this going to work in really cold? We're in the Florida, we're worried about air conditioning load. You know, he says, he's like a proverb. He says, yes, but isn't cold the opposite of heat? I'm like, oh, okay, right. So it works equally well in cold or hot, right? Because it's about a heat load,
Right.
or heat loss, right? It's the same thing. Doesn't matter which direction it's going.
Okay, that actually makes sense.
Yeah, it does.
Okay.
Yeah.
And along with that vein, then, I guess my next question would be, would there be issues installing like wood stoves going through these panels?
No, I mean first of all, polystyrene is a safe legal insulation in all over the world, right?
Right.
The styrofoam cups we drink out of, you know, it's not an uncommon material, right? And so, like any penetrations through a building wall, if it might require fire caulking, it might require sealing. That's part of our specification. We draw the plans to make sure that we've met the international code for pipes passing through walls. But I would say that the buildings are so efficient that in Florida, people often put fireplaces and stoves, like Potbelly stoves, in their house.
Mm-hmm.
And it's like I tell them you better run it with all the windows open, because you only get in 5 minutes. It'll be so hot in here, you'll be in trouble, right? So
Well, that just means it's cheaper,
it's
right?
just so the average. So when we do it, when we do the calculation for the operation for heating and cooling in Florida, the cost to operate per year is about for air conditioning is about like $300 a year for the air conditioning,
Wow.
and it's like $20 a year for heat.
Mm-hmm.
Because the building, actually in my house, the compressor for the air conditioner running generates heat, and it heats the house. Okay.
Wow.
So after the hurricane, our house is like, we have it cranked down cold because we know we're going to lose our power. Where we live is a remote spot on an island.
Right.
And so we crank it down to like 65, and then the power goes out. It always does. And so for like 2 or 3 days, we're comfortable, right? It creeps up very slowly because we have really, really good envelope. My neighbors who have frame homes, in like 30 minutes, they're in misery,
Mm-hmm.
right? And so we're fat and happy in our houses. A little Honda generator, 2,000 watt, runs an air conditioner in the bedroom, 2 fans, phone charges, and it keeps the refrigerator running, right? So, and the TV,
Oh, that's fantastic.
the satellite dish, the Tesla, the Starlink.
Starlink. Gotcha.
So everything we need to live.
Right.
The thing that you need though is a comfortable envelope, because if it's 90 degrees in the house, you can't sleep at night, right? Even with a fan, it's terrible. But with ours, it retains that, it banks that thermal condition that you leave it with, right?
So I'm guessing that you've probably already figured out, but how much stronger are your panels than traditional stud walls?
Oh, they're many times stronger, right? I mean, look when trees fall on frame houses, what happens? You see these pictures just collapsing through.
Mm-hmm.
The tree that hit our house in Hurricane Ian, almost 4 feet in diameter at the base,
Right.
140 feet tall. It's about 40 feet from the house. It crashed into the ridge. We saw it coming. It was blowing 200 miles an hour from the east.
Right.
And we're just in like Alice in Wonderland, looking out the windows and pacing around, watching this happen. We thought the hurricane was going to pass by Tampa. We didn't expect it to run exactly over us, right? And I said, the tree's falling. We ran across the room and jumped on the couch, and it hit the house, and one picture fell off the wall. We're like, that's it? That's it.
Wow.
So otherwise it would slice through the house and kill, because you have trusses or frame members every 2 foot on center.
Right.
It just hits between them, and it's just 1/2 inch plywood. It just goes right through like a scissors. So these things are massively strong that way. We had another giant tree strike similar on the U.S. Fish and Wildlife Ranger Station in Wausau, Georgia, which is in Savannah. It's on Wausau Island out in the Sound. And it's crew quarters and a research station for the island for native species. And a giant tree hit in Hurricane Dennis.
Right.
Fell, and it was 3 foot diameter, longleaf yellow pine, 150 feet tall, crashed into the ridge and just went clunk, right? Otherwise, would have gone right through.
It would have sheared.
So it's a very strong monolithic form, right?
Mm-hmm. Wow. Well, I am super excited to see how this all goes together today.
Today, we are. CJ said we'd like to, for our friends, we'd like to show you principally how buildings go together, and so I walked in the back and saw it was on hand. It wasn't already obligated to another project, and on that basis of that, I drew a quick sketch of an emergency shed. It'd be a thing that you could put in the backyard, anchor down, and make an office or a she shed or a safe room, for a disaster. And since we don't have time to pour concrete and put or dry piles, we just put some panels out there, made a quick foundation, and in 30 minutes we have a platform, and we'll go out there. We're going to make panels. We're going to cut panels. We're going to go over there and we're going to stand panels up, right? We'll see how far we can get.
Oh, this is going to be fun.
Yeah, no doubt about it.
Super excited. All right. Well, thank you for answering questions.
That's cool.
I'm sure I'll have something else that'll pop in my head during all this process. But
sure.
I can't wait to see how it unfolds.
Me too.
All right. Thanks.
Yeah.